Hi guys, today we're going to learn about the natural logarithmic function and differentiation. Let's start with the definition of a natural logarithmic function. This is defined by natural log of x is going to be equal to the integral from 1 to x 1 over t dt where x is greater than 0. The base of a natural log is the number e. E was named after the Swiss mathematician Euler. Okay, you know that E, in case that you don't know, is defined as the limit when n approaches to infinity of 1 plus 1 over n to the power of n, as you can see it here. Similarly, you have that it's the same as limit when n approaches to infinity of n plus 1 divided by n to the power of n. This, whenever you take the limit, is going to approach to 2.7183 and so forth. Okay. Another thing that you learn in algebra 2 is that y equals natural log of x and y equals e to the power of x are inverse of each other. Another thing that you learn back in algebra 2 is the properties of natural logs. Okay. The domain of the function y equals natural log of x is going to be from 0 to infinity. The range is all real numbers. If you remember from algebra 2, you have a vertical asymptote over here. Okay, then you have a situation that looks like this, and you were crossing the x-axis at 1. Okay, so this is the x-axis, this is the y-axis. Okay, the range of this function, it's all the real numbers. Okay, the graph of y equals natural log of x. As you can see, it's continuous on its domain, increasing and 1 to 1. The graph of y equals natural log of x. As you can see from this example, it's concave down all the way. Okay. Other properties that you might need to remember from algebra 2 are the following. If we have that a and b are positive numbers and n is a rational number, then what you have is that natural log of 1 is going to be equal to 0. That's a property that you learn in algebra 2 and pre-calc. Natural log of e is going to be equal to 1 because of the property of them being inverse of each other. And then, super important, you need to remember that when you have the natural log of a times b, all of this is inside the natural log. You can break it into natural log of a plus natural log of b. Similarly, we have when you have a quotient inside the natural log, you can break it as natural log of a, which is the top one, minus the natural log of b. Note that the negative is in the one that is in the denominator, okay, in the variable that is in the denominator. Okay, both of them, you have the natural log in front. Another one that it's very important is the power property. Remember that you were taking the n to the front, so you have that natural log of a to the power of n is equal to n natural log of a. Please don't confuse this with this. This is completely different, and this one is another story. Okay, and we're going to see examples like this. This is not the same as this one, not. Okay, so let's review some algebra 2 here. If we have all of this inside your natural log function, okay, what are you going to do to expand the situation? Okay, so the first thing that you can do is you can apply this property. So you have that this is going to be the natural log of x squared plus 3 to the power of 2 minus the natural log of x squared plus 1 to the power of, that's a 1/3. Okay, so but this is not completely expanded because I don't want any exponents. Okay, so what you need to do is you pass the exponent, use the power property, so 2 natural log of x squared plus 3, and then over here similarly you have negative 1/3 natural log of x squared plus 1. Okay, here remember that this we cannot break it. When you have an addition or subtraction inside the natural log, you cannot break them, so it would stay like this. Okay, so that's what we have for this example. The next one that we have over here is exactly the opposite. We have something expanded and they want you to condense the situation. So what I would do is I would write a big parenthesis. What you can see here is that this is going to be at the top because this is a positive situation. So you have that it's going to be x plus 3 to the power of 2. Similarly, this is going to be also positive, and you can see that it's a 1/2, which is going to be a square root. So you have that this is times the square root of x minus 2. Okay, everything inside the square root, and that's what you have. Okay, you don't have any denominator because you don't have any of these terms being negative. Okay, if you want to put a dot here so you know that it's about the multiplication, go for it. Now let's do the calculus here. So what's the business here? The derivative of, with respect to x, of natural log of u being something, is going to be equal to 1 divided by u times the derivative of the u, with the u being greater than 0, excuse me. Okay, so this thing, okay, that you have inside the log, you're going to do 1 over the thing times the derivative of the thing. So meaning, what do you have here? We have y equals natural log of 2x. So what we have here is 1 over the thing, which is 2x, times the derivative of 2x. What's the derivative of 2x? You know that it's 2. From this equation, you know that I can cancel my 2's, and I have that it's 1 over x. Do you agree with that? Let me tell you another story. Here, this one, if you use properties of logs from Algebra 2, you know that this expression is going to be equal to natural log of 2 plus natural log of x. Do you agree with that? If you take the derivative of this equation instead of this one, you're going to get the same thing. Okay? It's a different process, but it's the same thing. So this is a constant, so that's going to be a 0. And this derivative, by definition, you know that it's 1 over x. So this is going to be 1 over x. So you can see that both ways you end up at the same spot. Okay? So for this example, we have f of x is equal to natural log of x squared plus 1. So what you're going to do here is you're going to do the same process, 1 over, and here you have x squared plus 1 times the derivative of the x squared plus 1, which you know that it's 2x. So in other words, what you can do here is rewrite it, but there's not much that we can do here. Okay? This is as good as it gets. Okay? Over here, what you can see, this is a product because you have the multiplication of x times natural log of x. So you do a product rule, okay? So I'm going to write it here, product rule, so you remember, okay? So what you have here is the first one times the derivative of the second one. The derivative of natural log of x is 1 over x, plus the second one, which is natural log of x, times the derivative of the first one, which is just 1. Summarizing this equation, you can cancel this 2, so you have that that's a 1 plus natural log of x, and that's it. Wasn't that simple? So the next one that we have, it could look a little bit more complicated, but try to make it easier. There's several ways to approach this problem, but this is how you can make it pretty simple. So do you agree that this is equal to this? Okay? And if I use the properties of logs, I know that this is going to be 1/2 natural log of x plus 1, right? So if I take the derivative of this expression, okay, instead of this one, I have that it's going to be 1/2 times 1 over x plus 1, because it's the derivative of the natural log, times the derivative of x plus 1, which is 1. So summarizing this equation, you have 1 over 2x plus 1, and that's your derivative. Isn't that simple? Of course, you can do it using the square root inside, and it would be longer, but you would get exactly the same thing. You can try it, okay? Okay, so the next one that we have over here, it might look a little bit intimidating, but don't let the annihilation of the natural logs to intimidate you. You know better. The derivative tells you that it's 1 over the thing inside the natural log. Inside the natural log, you have another natural log, 1 over the thing, times the derivative of this guy. So what's the derivative of natural log of x? You know that it's 1 over x. So this one, you can express it as 1 over x times natural log of x, and that's pretty much what you have for this problem. So you can see that it seems a little bit intimidating, but it's not that bad. This one, again, you have several ways of approaching this problem, okay? So we can do it as it is, 1 over x cubed times 3x squared, because that's the derivative of this guy, and then you can simplify, okay? And you have that this is 3 over x. Isn't that nice? And the next one that we have over here, this one you cannot do it another way, because you cannot simplify using natural log properties. So the only way that we can do this one is via the power rule, chain rule. Okay, so you have 3 times natural log of x power 2, and then the derivative of the inside, which is 1 over x. You can leave it like that, or you can leave it like this, 3 times natural log of x squared, and then everything divided by x. Honestly, both ways are the same here, okay? Any questions? Good? Happy? Okay, so let's do the last problem of this section, okay? So in this problem, they are asking you to show or prove that y equals x natural log of x minus 4 is a solution to the differential equation x plus y minus x times y prime equals 0. So we're like, okay, so we have our y here, okay, so we know this one, but I don't know what's the business with y prime. But you know better. You're like, okay, so we can compute y prime from this one. this is a product rule, so you have the first one times the derivative of the second one, plus the second one times the derivative of the first one, and then the derivative of the negative 4x, you know that it's negative 4. Summarizing the situation, this is a 1, okay, 1 minus 4, that's going to be a negative 3, okay, so you have that this is natural log of x minus 3, okay, so this is your y prime. So now what I'm going to do now, okay, let's plug the values that we have of y and y prime, okay, into the differential equation, okay, the differential equation, this one. So you have that x plus, and instead of y, you're going to plug this thing. So you have x natural log of x minus 4x, and then you have minus x times y prime. The y prime is natural log of x minus 3, okay, so compute all the situation, okay, so we have that this is going to be x plus x natural log of x minus 4 minus x natural log of x, because I'm distributing this guy here and here, so plus 3x. And when you compute this, you can see that this is a like term of this one. Then we have that this guy is a like term of this too. So we have that this is 0. This is really good because we have the 0. Okay, so the inequality, this equation holds and it's true. So what we can say over here is we can say that thus, okay, y, okay, that it's, what's y? Y is this one, okay, is a solution, okay, solution to the differential equation, okay, provided, okay, we can put it here, y, x plus y minus x y prime equals 0, because the equation, okay, is holds, okay, holds for the situation, okay. So that's what we have here, and I know that sometimes you feel that this is redundant, but when you are doing a proof, you do need to conclude, okay. So that's it for today. I hope that you find this video helpful. Bye.